We basically build barges that are over 100 foot long, hundreds of tons. Well, we have roughly 300 employees here. I'd probably say 175 to 200 of them are welders. We do submerged arc, we do flux core welding. Every 2 days, one hits the water here at BMP.
The Flextec 350X is the 350 amp machine that accompanies the rest of the Flextec platform. So we have a Flextec 650, a Flextec 500, and now we have the Flextec 350X. The X is the indication that we have this new technology called Crosslink, which allows me to transmit voltage commands across my welding power cable. It was designed to be very simple, very reliable, but give you arc characteristics that you prefer, which are produced by inverters. So these machines can be used in all sorts of applications, inside, outside. They can be stored outside. They're designed to be just as reliable as that platform.
The winter is really, it's really tough. It gets brutal, in the winter time, and we do get a hot summer.
It's crazy hot in the summer and extremely cold in the winter. This building here is like an ice box in the winter, and it's like a heat box in the summer. So the machines take a beating. We definitely rely on the product to be able to stand up to all those conditions. I think that Lincoln does a great job at providing us with that equipment.
Crosslink technology is a communication protocol that exists between the power supply and the feeder, and that's going to solve three problems for our customers. One, it's going to make their job sites safer. If operators don't need to be walking around the site, it's going to keep them in a safer position. Two, it's going to improve the quality of our customers. If they have the ability to adjust procedures at point of use, it means the operators are going to use the right settings all the time. And three, is going to improve their productivity. If a person doesn't have to leave their work center, traverse across the job site, climb out of a hall, for instance, or climb down off a structure in order to go back to the machine and change the settings, it means they're going to be behind the arc more often.
There's a lot of confined space. A lot of out-of-position welds in our shop. We have the most of it. The hassle is we could be 100 feet away from our power source. And then you have to climb a ladder and then down a ladder. So you got to figure we're going inside the barge and coming back out. You're losing a lot of time.
There's pretty much a wire leading everywhere. There's probably 3 or 4 miles of wire here. You could literally be gone 30, 40 yards, if not better. And outside, you're even going more. You might be going 120, 140 feet to get to where you need to be. So having the controls right at your fingertips, right in your work area, that sets the bar right there.
Just setting it up. If you're by yourself, you're probably at least a good 10, 12 minutes, unless you got somebody you can holler at, to change your machine, And then you're going to do the same thing for him too. You're going to yell up there and adjust his machine.
So in all the customers we've worked with in order to test this type of protocol, we've been able to solve all their distance applications in regards to voltage control across hundreds of feet. We haven't encountered a situation yet where the technology can't accommodate the distance being used.
You move a lot faster. We're able to meet higher demands for production. Lincoln is definitely a huge part of what we do here, and the advances they've made in their technology has kept us competitive in this market.